Hello guys, and I welcome you all for the today's video. And today's video is about the computer system architecture. So I am Lakshmi Vaibhavi and we currently pursuing BE in CSC AI at SVCE. So let's get into the topic. And in the topics we'll be having an introduction part, then components of computer system like CPU architecture, memory hierarchy, then input and output devices. At last we'll be having a conclusion. So first of all, what is this architecture? Architecture, if you take a building, will be having a blueprint, right? Like where does the room exist, where does a balcony comes. So likewise, we'll be having a blueprint for our system also. Then another example I could give is a human body. If you take a human body, you'll be looking into like where digestive system, nervous systems, then circulatory system are located, right? So the same way, computer system architecture is like a blueprint for a building. Just a blueprint guides the construction of a building. Computer system architecture guides the design and development of software applications. Without a solid understanding of the computer system architecture, software developers and system administrators could be like a builders without a blueprints, then building blind and hoping for the best. Of course, it's not a great job, right? To put it another way, computer system architecture is like a nervous system, as I said, of a human body. It's like a backbone that connects all the different parts and allows them to communicate with each other. Without a healthy nervous system, the body cannot function. So without a proper design and proper architecture, we cannot develop any software, right? So this is the introduction to the architecture of the computer. Then components of the computer system. The main components here we are seeing is CPU, then memory, then input and output devices. Finally, the storage devices such as the hard drives. So I could give an example for this. Why it is so important. Like if you take a ship, and ship navigation constant in the ship navigation, the CPU acts as a captain over there, making decisions and giving orders to the crew members. Memory would be like a ship's navigation and constantly updating the captains on the ship's location and trajectory. Then input and output devices would be like a ship's communication system, allowing the crew to communicate with each other and the mission control. Another storage and another thing, the main thing is storage devices would be the ship's cargo hold, storing all the supplies and equipment needed for the system needs it of various components to work together seamlessly in order to perform a task and efficiently and effectively. So this is the components of computer system and their introduction. You can see here it contains the memory devices, output devices, then input devices, CPU, motherboard. All these things are the components of computer. So let us see next thing, the computer CPU architecture. The main thing is, as I said, CPU acts as a captain. Then you can also say like brain of a computer. So CPU is a brain of a computer system. It carries out instructions that are stored in the memory and performs arithmetic and logic operations on the data. See, you're going to give the input, then the required operations for the user it is performed here. The required operations may be like controlling the unit, then earth ALU functions. Once it's done, the one set will be stored in the memory, the another set will be given to the output devices for the users. They fetch, decode and executes, and it also follows the pipelining system, which is fetch, decode and execute cycle is the process by which the CPU retrieves the instructions from the memory, decodes them and then executes them. The control unit coordinates this process while the register stores the data and instructions temporarily. The instruction set is the collection of the commands that CPU can execute, and it varies depending on the CPU architecture. So we are done with the CPU architecture, then we'll get into the memory hierarchy. What is the role of memory? Memory would be like a ship's navigation system, constantly updating the captains on the ship's location and trajectory. Likewise, in the system, it stores which file exists, what is the storage capacity of that file. So what is the path? All this comes in a memory hierarchy. So memory hierarchy, the concept of memory hierarchy refers to different levels of memory that a computer system uses to store the data. These levels includes cache memory, RAM and virtual memory. So ROM acts as the primary memory, then cache, then RAM as the secondary memory, which with each level having its own trade-offs between speed, capacity and cost. Cache memory is the fastest and most expensive type of the memory, which is located between the RAM and ROM, but it has its limited capacity. RAM is slower than the cache but has a higher capacity and is less expensive. Virtual memory is even slower than RAM but has much larger capacity and it is least expensive option. The trade-offs between these levels of memory are important consideration of the software developers and system administrators. The second main important thing is the input and output devices. This input and output devices is helpful in communicating between the users and a system. The input and output devices are essential components of computer system that allows users to interact with the machine. These devices includes like keyboard, mouse, printers, displays, among others, and each devices communicate with the CPU and memory through input and output ports, which are interfaces that allows data to be exchanged between the device and the computer. Device drivers plays a critical role in managing these interactions by providing a layer of software that translates between the device-specific protocols and standardized protocols used by operating the system. This allows the computer to communicate with the device without needing to know the details how it works, making it easier for a developer to write software that can work with a wide range of hardware configurations. So this is the useful points for the input and output devices. Then conclusion, what is the main agenda of this thing? In conclusion, understanding the computer system architecture is essential for software development and the system administration. By comprehending the components of the computer system, CPU architecture, memory hierarchy, and input and output devices, developers and administrators can optimize their systems for the better performance and efficiency. So there is a quote here, a fiction writer Arthur C. Clarke once said, "Any sufficiently advanced technology is indistinguishable from magic." By understanding the computer system architecture, we can demystify this magic and unlock the full potential of our technology. So the ones like you need to get into the anything to be built, you should be knowing the history, then basics of that. The same thing involves or implements in computer system software also. Before developing a software, we need to know about how it works, know what is the basic architecture of that. So that's all guys for the today, and thank you.